Hello everyone, my name is Omar Hadi and my group members are Hamza and Sharif. Objectives: you will be able to find the components of form of AB, find the magnitude of AB, create the equations of adding two vectors, solve real-world problems using vectors.
Okay, in the first slide, we'll be talking about vectors. What are vectors? A vector is a mathematical entity that has both magnitude and direction. Vectors are used to represent quantities that have two characteristics, such as displacement, velocity, force, or acceleration. For example, magnitude is the length or size of a vector, while the direction is the orientation of all vectors in a space.
There are two methods to adding vectors. Okay, the first method is the parallelogram. It involves constructing a parallelogram where the vectors to be added to adjacent sides. That also the second method is the triangle method, also known as the head-to-tail method, involves placing the vectors sequentially to form a triangle.
Going over the first word problem that we made, the question is, a soccer player is standing in the point 2, 6, kicks a soccer ball at an angle of 40 degrees with a horizontal that then lands in vector 8, 9. Find the component of AB. First of all, use the formula x2 minus x1, comma y2 minus y1, and we plug in the values, and then we simplify and get 6, 3. The x value is 6 and the y value is 3. Then we find the magnitude also using the other formula, and we get 6.7. And then for the next part, we use the same values and plug it into 3a plus 2b. Again, we use 3 and multiply it by 2, 6. And then we take 2 and multiply it by b, which is 8, 9. After we multiply, we get 6, 18 plus 16, 18, which if you simplify, gives you 22, 36.
What is the sum of the horizontal components of the tractors, and what is the sum of the vertical components? So fx, we will use the formula f cosine 40 and f cosine 40, which is for x and for y. For the first tractor with the force of 2000 newtons, fx1 2000, we will put the cosine and theta 40, and fy1 2000 sin the theta is 40, which is the angle. As you can see, the answers are for x1 1530 and for y1 1284 newtons. For the second tractor with the force of 1500, we will do the same thing, except we will change it from 2000 to 1500. And then we will add fx1 with fx2 and fy1 with fy2.
B. What is the resulting force on the tree stump? Minus F resultant equal square root fx to the power of 2 plus fy to the power of 2. F resultant equal 3434 newtons minus theta equal tan minus to power of minus 1 fy over fx. Tan equal theta equal 41 newtons.
Question C. Would changing the angle of the tractors affect the magnitude of the resulting force if the angle between the tractors remained 40 degrees? Explain. Altering the angle between the tractors would invariably modify the horizontal and vertical components of the forces exerted by the tractor. However, if the angle between the tractors were to remain at 40 degrees, the magnitude of the resulting force on the tree stump would remain unaffected. This constancy in the resulting force arises from the fact that it is determined solely by the magnitudes of the horizontal and vertical component of the forces exerted by the tractors. It's crucial to recognize that the angle between the tractor doesn't directly impact the magnitude of the resulting force, as long as the magnitudes of the forces exerted by each tractor remain consistent. Therefore, under the condition of fixed 40 degrees angle between the tractors, any changes in the orientation of the tractor would not affect the magnitude of the resulting force acting on the tree stump.
Okay, so what we did for the simulation is we took vector A, as you can see the letter A is written over the vector, and vector B, and we summed them up, and this is our final product. Thank you for listening.